Now we have our next speaker, Danisch. He is a software engineer and open source developer specializing in interactive visualization, GPU computing, and graphics infrastructure. He studied cognitive science at the University of Osnabrück, where his work on machine learning and computer vision led him to discover Julia in 2012. He created Makie.jl, Julia's high performance visualization ecosystem, and Bonito.jl, a reactive web framework for building interactive applications. With over a decade of full-time Julia development experience, he has contributed extensively to the ecosystem through packages including GPU arrays.jl, file.io.jl, and packagecompiler.jl. I would like to welcome Danisch.
Thank you. Let's see. Okay, but I tested this with HDMI and they worked. So it's detected. Yes. Well, that's a good start. Jesus. All right. I'm really happy to be here and talk about Makie and Bonito. And I promise I didn't just want to talk about AI to jump on the hype train, but I think it changes where Makie is going and how I will be working in the future. So I thought it would be interesting to talk a bit about it. I will be talking also about another exciting project I started last year, which is Bonito book. And I will present some improvements we have done over the last years and talk about Makie 1.0, which is finally very close. And what I'm most excited about is the new ray tracing ecosystem for Makie, which I'm looking forward to. And then I also refreshed some projects from last JuliaEO and will show them. And then a little bit about AI. Bonito book is a Jupyter alternative, which I got pretty much nerd sniped into because like every month or so I get someone who's like, why is Makie not super well integrated into Pluto or Jupyter? And there's really not that much I can do because yeah, there are some architectural differences which are really hard to overcome. But with Bonito, there was actually already almost everything you need to write your own book. Which I then started, and I think there are also some other reasons besides Makie integration. It's the first 100% Julia-based notebook system, which makes it very easily extensible from Julia. It's very easy to write new widgets. It's very easy to change the layout completely. And it's also the reason why I couldn't just change the computer, because this is a Bonito book presentation. And it's running on like different branches, and it's not that easy to set up yet, but I will polish this in the coming weeks. And I think it's perfect for tutorials, reports, dashboards, and like, yeah, everything that other people love about notebooks. And one unique thing about Bonito book is that it runs everywhere. And what that means is because of Bonito, it doesn't really care if you put it on a server and therefore serve it as a web page, or if you have it in the VS Code plot pane, or you could actually even have it as a cell output from Jupyter or Pluto, because that's what Bonito was about from the beginning, to have HTML getting inserted into like any kind of HTML viewer. And I just wanted to quickly demonstrate this. Because that also means it very easily integrates with Documenter. So this is actually a Bonito book, which without me doing anything special already works by default in Documenter. So I used that to write some ray tracing tutorials recently. And there are also some examples showing off a bit like how flexible it is. For example, this is a plugin for Bonito Book, basically turning it into a more scientific book-like format. And I'm actually planning to rewrite Julia and data science with Lazaro to use Bonito Book. So that way you can actually just download an executable of the book, and then you can just interact with everything in the book and basically rewrite it on your own computer. Like the flexibility also really shows, like here, this is still like a Bonito book, but it's a plugin which basically lets you completely change the layout and how it looks. Yeah, and the slideshow, obviously. But yeah, I think this is kind of cool, and I'm not sure how much of this is possible in other frameworks, but it feels like it's quite a bit harder in other frameworks. Yeah, and as part of some other project, and also for Bonito Book, I actually polished Bonito quite a bit and fixed quite a lot of bugs in the protocol, and like all, it's kind of hard that it's really recursive. You can have like a Bonito book inside a Bonito book and observables inside observables. So that was kind of buggy, and now it's, I think I fixed everything. And we are also did a very big refactor of Makie as part of the Sovereign Tech Agency investment, which improved performance a lot, especially for WebGL Makie. So here you can see like the green part is how much we save now with the new version. It's pretty significant, and I think it's a difference of if a project runs in WebGL Makie or not, because we are sending actually a lot less messages because we are we moved to a polling approach, which means now we can skip a lot of computations. Before that, we had to, if you updated anything in a plot, you had to do all the computation involving that, even if you don't render a new frame for that computation. And now it's only polling before actually rendering a new frame. This also cleaned up the backend implementation and fixed a few bugs. For example, multi-updates of attributes, which was previously kind of hard and buggy. And I finally got around to create some loading spinners for WebGL Makie. I think it's on Makie Master now, but not tagged yet. So soon you will see loading spinners if the plot takes a while to load. And this is actually also planned for Bonito apps. So before you had just like a white screen when a Bonito app compiled or took long to load. And now we finally have some spinners there. Yeah, all of this was also on the road to Makie 1.0, like having a more stable WebGL Makie backend. And other things that are missing were complex recipes, which means creating axes and legends and things like that inside a recipe for your own data type, which we now finally have a working PR open. We also have an open PR for automatic color bars and legends, which is it's a really small feature and expected of every plotting library, but in Makie historically we didn't have that because we tried to make everything super flexible and customizable. And that means it got a bit hard to make automatic color bars, because then, yeah, how do you work with that if there are already color bars, but you don't want them there and want to compose everything nicely? But I think we have now a nice approach for this, and it's also a PR. So all of the 1.0 features are in PRs, and are passing tests, most of them. So it's a matter of reviewing them and merging them, which is new because I think the last times I talked about 1.0, it was more in the future. And finally, a lot of people have been asking to in their recipe to be able to set some access attributes, because sometimes, like if you have your own array type, for example, where you have names, you want to set the title of the recipe by default if you're just plotting that array, which is possible now. And a much requested feature was having some UI elements, like saving a plot, copy and pasting a plot, and things like that, which is also up in the PR. So now it's just a matter of merging all of them and releasing it, and then I'm pretty confident to release Makie 1.0 because I don't have many more breaking changes planned. Now for the ray tracing, I've spent a lot of time to implement ray tracing really in Julia. It started with me seeing trace.jl, which looked really nice already. Someone put a lot of work into it. One big problem was that it was really slow and wasn't running on GPUs. And the first thing I did was spending lots of time on it to make it faster and make it run on GPUs. That took quite a while, but made me really optimistic that this is a good approach. This work basically went into RayCore, which is basically a ray triangle intersection engine that you can run on the GPU and on the CPU, and it's very performant. I think we are pretty close to state of the art, which is not that easy, and that's also where AI comes in, because I translated quite a bit from existing open source C++ ray tracers, and it worked surprisingly well. And I think in Julia the code is much more readable and extensible, which seems pretty novel to me because ray tracers have been these huge monsters which are really hard to extend and work with. And I think now having them in Julia will make a big difference to actually have more people play around with it. Yeah, and another package is Hickory, which is basically the old trace.jl, which we renamed because trace is already registered. And this is actually implementing the more complex materials and lighting models based on RayCore, pretty much. And then the final piece of the puzzle is actual Makie integration, which is happening in Trace Makie, which is already pretty far. This is a Lego scene I'm showing of animations, now with shadows and everything. This has been working before with Radeon Pro Render in Makie, but now the Trace Makie is far enough that this actually works. And this video was rendered in 12 seconds, which is really fast for ray tracing. I think the first version of Trace, before I optimized it, might have taken a couple of minutes for this, with less quality, I think. And another exciting thing that happened is the folks from Breeze contacted me that they're really excited about ray tracing because they needed to render their clothes. And I managed to very quickly integrate it with Hickory, also with the help of Claude Code, because I don't actually know these algorithms that well, but now it's relatively easy to just port these materials to Julia and then plug them into the existing ray tracing framework. And I think the results are really beautiful. This is just a very low resolution cloud, and it still looks already pretty nice. I also implemented some post-processing, which is pretty important for ray tracing because it's closer to photography, so you might want to change the exposure and things like that. And there are certain pre-processing models to remap the HDR images to the visible range. yeah, and this is very exciting for me because it shows how that this actually works. And it's fast. This renders in 0.3 seconds, and it's not even on the GPU. And there's still a allocation bug in there. So I think this will render in... I had it working on the GPU a few weeks ago, but then it broke again after some refactors. But I think this kind of image will render in 0.01 seconds or so. So it's almost... I mean, it's already here, ready for interactive use, I think. And the ugly thing you see here while rotating, that's actually Makie. That's what you would get without the ray tracing, basically. So I think this is a pretty nice improvement for fidelity. Yes, now we are already at the throwback to JuliaEO26. We started developing Tyler there, which I think was a really fun project, and it's still living, and people use it actually. One of the coolest visualization was from Alex at the Jet Propulsion Lab, who is working on tracking glaciers. And he made a really cool visualization with it, with real data of tracking a glacier. Yeah, so you can plot on top of it. It renders all kind of tile sources. And it also works in Bonito book, hopefully. So here you go. I also tried to polish it a bit for this talk. I hope I improved the tile loading a bit, and like at the end of the week, we can make a nice release of Tyler, because it was a bit, yeah, not that many people worked on it in the last years. Although there was constant activity, I think, on the repository. What I did, I think 2 years ago, was Julia Hub actually asked me to implement 3D rendering in Tyler. So now you have like this cool 3D map with like elevation data. And we actually also added some other tile sources, and you can, if you have like data on the globe with 3D data, you can write your own plugin basically to load from there and display it and plug into this. Yeah, another project was AndyViewer that got started here. It supports loading any dimensional data array. I still have Yax array in here. That got lost somehow. But Yax array as well. It offers a simple YAML syntax, but also like a dict-based syntax to define what kind of data slices you want to map to a certain Makie visualization primitive. And then it creates like an interactive app out of this. It also has basically plugins, which are just, in the simplest form, it's just a Makie recipe, basically, which you can then also address from the YAML syntax. Yeah, and this also works in Bonito book, and you can put this on a web page or into any other Jupyter alternative or notebook, which is also thanks to Bonito here and WebGL Makie. So I think this is pretty cool. The Air Center, I think, also published something like this, but I'm not sure if it's online. Okay, yeah, but this will be interesting, I think, to see that in production. Yes, and finally, a few words about using AI in Julia. First of all, I'm using MCP REPL, which is very important, because without the LM being able to actually run Julia code, it usually doesn't understand the code base as well, and might actually use outdated functions and stuff like that. But if it can just run code, it very quickly adapts to that. And I've had like some really nice success stories to just one-shot dashboards. You can even show it sometimes a picture and say, I really want to have this kind of dashboard, but with my data and my packages. And it sometimes works and sometimes doesn't, but usually gives you a good starting point. So I think right now is a good age to try out new languages and new tools, because it became so much simpler to get started. It's also great for translating from other languages to Julia. As I said, with the ray tracing, that was, I think otherwise without Claude Code, this could have been a 1-year project or something like that. But because it has become so easy to go into existing open source projects and translate it to Julia, it becomes very easy to close gaps in the Julia ecosystem. And it's also really good at mundane inspection tasks, like telling it run code warn type on any Julia function in my project and check for type instabilities, which are bad for performance. And then it will usually be able to fix them really quickly, and will do that for 100 functions without problem. Yeah, and like review codes or go through the documentation and make sure it still makes sense. Yeah, and this actually, I think, I've used it to improve the Makie documentation. It's still a PR, but will be merged pretty soon. And it also inspired me to structure the documentation better to be accessible from Julia as well, so that you can look up documentation and have like a starting point which explains how the Makie documentation works, which is obviously also good for humans. But I hope this will help much more to get people started. Yeah, and the missing gaps in the ecosystem have been quite clear for me and pretty problematic sometimes. For example, I've been wanting to have a GLTF loader for quite a long time. It's a relatively complex 3D model format, which allows you to, in one shot, basically load a whole 3D scene into your language. And that hasn't existed yet. And it's a pretty complex format. And I was able to implement it in half an hour, an importer for this. And that's how you get like fun 3D models like this into Makie now. It's also not published yet, but this is also like one of the first prototypes of the new ray tracing framework to render more complex scenes. And that's already it. Thank you very much, and I'm happy to answer any questions.
Thank you. Okay. Well, I'm very interested in the use of parallel computing for artificial intelligence. And since you are describing the advantages of Julia in doing artificial intelligence for this specific case, could you highlight a little, in short, I know you spent a few minutes talking about it, but what is the advantage of Julia in relation to other also languages that also can do parallel computing? And so, of course, people have been using them for AI. Thank you.
Yeah, that's a very good question. I should have highlighted this more in the talk. I think Julia is in a really good position there because complexity also matters for LLMs. The longer the code, the more difficult it is for the LLM to reason about it. So terseness actually improves the code output of LLMs. And Julia, there are a lot of plots for this. Like Julia is really at the sweet spot of being terse and performant. And the other thing is to be able to just evaluate a function, run it, test it, and actually get the LVM code from it, the GPU code from it, the type code from it. That's introspection you don't have in many other languages, which really helps the LLM to understand the function. So yeah, I think, yeah, I had a lot of functions that weren't working well, and then it just looked at it with code typed, and then it found the problems with it, and then it suddenly understood the function much better. So I think that's a very big point. Yeah, and I mean, I don't know how it is in C++, but I find it hard to see the workflow of compiling your whole code base and then running something. It obviously works, but it feels much easier in Julia. Sure.
Awesome. And one thing I wanted to highlight is some of the features you've added, the color bars and things, I think are going to really maybe improve the how many people switch from plots to Makie. So I think as a community here, we've always been very excited with Makie and delighted about all of the progress every year. So I think great work. And I was wondering if you had some sense of, at this point in time, where Makie is compared to the general use within the community in terms of plotting, compared to, say, plots and other things?
That's a very good question. I don't have a good sense of that. I only have a gut feeling. And my gut feeling is that for more complex projects, most people start to use Makie in the Julia ecosystem. There's a long tail of like very simple plotting tasks where most people avoid Makie because of the compilation times and that it's kind of heavy and that it's missing like the UI to save plots and things like that. So I feel like people that very quickly run one script and do one simple plot that doesn't need to get tweaked usually don't use Makie as much. But it seems like everything I read online where people talk about plotting in Julia, it seems the conclusion is to use Makie. So that feels, yeah, like that's a very good progress there.
Great. And I guess I'll add that I'm going to try Bonito book soon.
Cool.
Yes, very impressive talk. So all this work you've been doing with the ray tracing, it looks a bit like it goes quite beyond what we normally consider plotting. Do you have any ideas or of applications that you wanted to dive into, or do you want to do more like a graphics interface? More animations, graphics, what kind of things?
Yeah, that's also a very good question because I'm pretty excited about it because I think this backend will open up a lot of possibilities because it's written in Julia and modular. So there are certain kind of visualizations where people have been wanting to have callbacks for every pixel basically you render, or really have callbacks on the geometry of the visualization and things like that, and they need to be very high performance, which is now possible since it's all running inside Julia. And the other thing is, since it's kind of modular, I got quite a lot of feedback of people who want to use the ray tracing in completely different areas like simulations, which is really cool because they are also having really high performance demands, like simulating heat transfer on satellites, for example. And there are already users there that use that. So they use Raycore in their simulation. And this is really cool because they will also be working on the performance and things like that.
Yeah, and I have a question on AI. I absolutely agree with you that in the age of AI, a step to learning a new language becomes actually really like there's not much of a barrier. Whenever I say like, hey, let's do this like bit of teaching in Julia, none of the students would ever complain. They just go to ChatGPT and like, how do I do this? And all the more senior academics say like, why do you introduce a new language? I'm like, it doesn't make a difference.
Yeah.
Does that actually mean that for, I think especially plotting libraries, I see more and more people interacting by literally just asking, prompting like, I want this, can you do this, and so on, that you would build Makie in a different way so that in the end you can either write your lines of code as you normally did, or you literally just talk to someone and say like, can you move the legend to the right? Can you do this? Can you do that? And it would basically just understand all the Makie stuff. Because I feel like especially plotting is something where you always like visually have an idea of what your plot is supposed to look like, but actually finding all the knobs of how to achieve that is tricky. And so maybe AI will change that drastically.
Definitely, that's a very good point. I'm thinking quite a bit about it. Because I've also been using this to create plots. And it's very funny because usually you don't watch, or I usually don't watch Makie users, how they create their plots and what problems they run into. And when the AI is actually just doing it in front of my eyes, I'm seeing like, oh, it's getting actually stuck there because that seems to be a difficult to understand API. So I think our layouting system, for example, might need a rework because it stumbles upon this quite often, and I also stumble upon our layouting system. So I feel like this will be something basically, I mean, inspired by AI is a bit silly because people also run into this, but it definitely showed me that there is something we need to change to make it much easier to create plots in that area. And the whole moving the docs more to Julia and making them more explorable so that you have like an entry point and then you see what's possible and then you can dive into the documentation from Julia is also something that I'm prioritizing for LLMs to make it more easy for it to actually create dashboards with Makie. So there's definitely things I'm thinking about. All right. Thank you.